Okay, then. So I think we'll get started. People are still arriving, but we don't want to wait too long for everyone who is more or less on time at the top of the hour. So welcome to another RiskCan webinar on compound extremes. And today we have one talk by Andrew Kruczkiewicz. Is that an accurate enough pronunciation?
Yes.
Sorry, my dog was barking. Hey, cut it out. So Andrew is a senior staff associate at the International Research Institute of Columbia University. And he mainly focuses on how remote sensing can be applied to develop early warning systems for extreme events, with a particular expertise on floods and their humanitarian impacts. And then he's also a technical advisor specializing in climate risk management at the Red Cross Red Crescent Climate Center, where he puts this knowledge into action. And so he is very much on the implementation side of climate knowledge, I think much more than a lot of us anyway, certainly more than myself. So it's very exciting to have him here to talk about the compound elements inherent in all of that work. And yeah, take it away, Andrew. The floor is yours.
Thank you so much, Colin. Appreciate it. Yes. Okay. Let me get my presentation up. Let's see. So, all right. And share. Let's see. All right. Colin, give me the thumbs up that it's working. All right. Hi, everyone. Andrew Kruczkiewicz here, calling you from my house in Brooklyn, New York. I'm very glad to have this opportunity. First of all, thanks to all the organizers, Colin, Mona, Kai, and Cass, and everyone else who makes this series possible. I really appreciate raising awareness and attention to not only the science side, let's say physical science side, related to risk and compound events, but of course also the policy and practice. And I'll be talking maybe a bit more, well, talking about all three today. Hopefully we have enough time. I think we will. But yeah, just a little bit about me, as I think it's important. I think it's my responsibility to talk a little bit about like how I got to where I am. Yeah, I am a meteorologist by background, actually. So as we were talking about before, Colin and I, if people know my Twitter handle, yeah, I am a weather nerd as a little kid. I didn't really know that I could work in this space. I didn't even know this space existed, but in terms of being a meteorologist / climate scientist working for the humanitarian sector, I'm very happy that I found this role. And yeah, and I talk a lot about, not only to my students, but more broadly about the importance of having people operating at the interface of climate science and meteorology and the humanitarian sector, and not just on necessarily like let's say advisory or secondments. Like my position at the Red Cross is more structured than most. So I've been there for almost 10 years, having an official role within the Red Cross, and I think we need more of that. I think we need more positions that are, from a career path perspective, situated at this interface of science, policy, and practice, not just once off or ad hoc sharing of support or translating, but making that someone's career. And that's really what I've done. I'm very privileged to operate at that interface. I'm very privileged to have a position at Columbia as a scientist and able to do it. But I am really encouraging a more, let's say, more deeper reflection on this type of work and the roles that can be more sustainable from a career perspective. Because many times I do feel like either in the scientific community, not a full scientist, because I spend a lot of time working with the humanitarian sector, but then the same in humanitarian contexts I'll talk about today, you're still not a real member of the humanitarian community either, because you still have this refuge back at the Ivory Tower in New York and other places. So it's hard. It's definitely hard to build a career around it. And I encourage everyone who's interested in to do it. But I feel responsible just to talk about the challenges as well as the success story. And that sets up my talk today. I feel like there's been a lot of talks lately and a lot of papers out there talking about the success of modeling, not only compound risk, but even individual hazards and risks around that. And these success stories of anticipatory action, forecast-based action, early warning systems. The challenge is in practice, many times they don't really work in a sustainable way, let's say, perhaps in a once-off case study perspective. But a lot of the work that I focus on is working with humanitarian organizations to design sustainable and accountable programs that integrate climate information and risk information within standard operating procedures that align with the governance structures of that organization. And that's much harder than just developing a system for triggering push notifications, let's say. It's a different story than alerting or early warning. It's thinking much more about what turns that early warning and alerting into action in a sustainable, accountable way. And then making sure we're thinking about the most underserved populations. I'm avoiding vulnerable. Some people might say the most vulnerable, but the most underserved in the traditionally and systematically deprioritized populations. Because to me, we need to focus more on that in terms of success stories of disaster risk. Are we really supporting those and decreasing that disproportionality? So that's just a start to the talk. And will this work? Yes. So the way this talk is going to work is we're going to, I got it. Colin, how do I move the top bar up here? Is there a way to do it? Hold on, more. That's okay. I can't quite see the top line of my screen, but that's fine. We're going to start off I'm going to go through
There should be, but I don't remember quite, sorry.
That's okay. Oh, remove control? No. Talking about identification of candidate data and derived products and tools. I call this section, which map do you trust? And then we're talking about the actual integration. I separated these on purpose. The identification of candidate data sets, what do those processes look like? And then integrating data into humanitarian decision-making. And there's 3 case studies we're gonna go through. I call this section too many maps, too little time. Maybe some of you, if you heard me talk before, you've heard that phrase, because that's real in many humanitarian contexts. In the most complex context, that is a reality. Then we'll go through questions and trends, some thoughts that I have to start the discussion. So the other thing on this slide, you may see on the bottom right, there is a triangle on the bottom right. And I say this every time, but it's actually true every time I show this triangle. Every time I'm thinking about I'm pulling slides together and I'm thinking, do I show this boring triangle or not? And I'm always kind of embarrassed because I'm like, I need some support from a designer to help me develop something more interesting. It's like the most basic shape and font, everything. But I left it here for discussion. And what I'm going to do is highlight it to make it bigger here. And essentially 2 things. One, me, as in my professional life, I think about this a lot. Where do I fit within science, policy, and practice? And I don't necessarily think that's just my whole career or all of my work. If I thought about it more holistically, I'd position myself more on top here. Actually, can I use the annotate feature? Wow. Let's try. I would position myself right here. Does everyone see that star? That's the first time I ever used that feature. So I position myself up to the top. That's my perception, because I do consider myself a quantitative scientist, and it's more of my comfort zone, let's say. But for every project that I'm engaging with or supporting an organization think through different strategies, that could take place in different parts of this triangle. Like, for example, right now I'm working with one of the UN groups on thinking about this idea of overshoot. What are some of the elements of overshoot we should be thinking about? And that's more on the policy side for sure. It's really not, there's a little bit of science going in there, but it's thinking about operations and also policy. So I don't know, maybe in this particular project, I'm down here, but I use this, and I share this with my students. I share this with my team at Columbia. We think about this, and it helps us plan out our approach. It helps us plan out how we're going to talk about things like uncertainty. Helps us think about our responsibilities and the ethical considerations when we're propagating a data set or a map or a derived product. When we're endorsing it or perhaps perceived to be endorsing something, where do we fit within this triangle? So I thought we'd take 30 seconds, and this might not work, but I hope it does. Is everyone able to access this annotation feature? Colin, do you know?
if you're able to access it, you don't have any special privileges, so everyone else should be able to as well. I actually don't see where it is though. Is it?
Oh, I see somebody
no.
just put their thing. Great. Awesome. So thank you for the two people who put their stamp. So
Can
yeah,
you, Andrew, can you say where it is?
the annotate's on the top bar. I don't know if it's top for everyone. My toolbar is on top of the screen. You might have to click.
Mine's
Oh,
bottom
under
left.
view options for me, and then annotate.
Okay,
There's a
great.
little pencil in the bottom left for me.
Yes, annotate. I have the pencil too. So if you click on that, then there's a stamp feature. So everyone select your icon of choice. And I think I could,
Interesting. Yeah.
and then we could go to stamp, and then yeah, take a minute to think through this and indicate where you think this also helps me understand the audience today.
This must be designed for, oh, mine is red. Oh yeah, this is the first interactive activity we've ever done, actually. So it's sort of
Oh,
fun.
good. I'm very
Exciting.
happy.
Oops. Oh, now I'm all over the place.
That's okay. I mean, I think this is perfect. We see some unexpected artifacts in here, but I think that's also relevant in the work that at least I do, and perhaps many other people as well.
Yeah, we were
Okay.
hoping for the webinar to be the audience to be more toward the center of the triangle, but in practice, yeah, this does not surprise me.
Yeah, but that's okay. I think that's, I mean, this is also my experience, you know, in talking about these topics. Tend to see most people more on the science, and science could be qualitative science, social science, however you define science, we're saying here. But it doesn't surprise me. I know that maybe this isn't the most traditional way to run the webinar, but I think this definitely helps me get a sense of where we're all coming from, and hopefully will help you all think through like where you fit within this discussion, and also how you can contribute. Does anybody want to share why they placed themselves where they did, or their thought process in placing their stamp? Maybe we could take, you could either write it in the chat, or also if you just want to speak up and share, yeah, your thought process in doing this. Let's see, there's so many stamps. There must be one person that wants to talk.
I can jump in.
Thank you, Kaz.
Yeah. So I think I was this one. I work in a government agency and I do research, but we don't do policy, so I'm not here. I'm closer to the science, but there's got to be a practical application. So sort of, I feel like that fit relatively well.
Okay, good. Thank you. Thanks, Kaz. Anyone else, or we'll move on? We don't need to dwell too much on this.
I can add
Yes,
something.
yes,
as an academic, I put my one of the many stars at the science top. I mean, I like that we all say in science that we want to contribute to policy and practice, but I would definitely not feel comfortable saying that I actually am, or claiming that I am. So hence the star on the top.
Thank you. I appreciate that reflection. And I also think that feeds into the second example, especially that I'm going to give in Bangladesh, where there were many scientists wanting to support the refugee camp response in Bangladesh. And me actually being there, working with IOM and UNHCR, a good amount of my time was writing messages to scientists to basically say, you're not helping and please stop. It was just too much data and not a sufficient level of willingness to really understand if and to what extent their data, their amazing forecast product or amazing tool was actually being used. So I think that's important, though, for us to understand that. With this push for scientists to be involved, I think we need to be involved as scientists, but there's also limitations, and we could actually be making things worse. And I think that's a very important message that I have. So we'll talk about that a bit more. Moving on from this, I'm so happy that annotation exercise worked. We did not practice that. All right. You know, oh, now we can't get rid of them. Now I can't get,
I can clear them. You can just carry on. I figured it out before.
So, you know, I was going to go through an example of seasonal forecasts, but I have a sense that most of us, especially given where we are on the science side, we probably don't necessarily need to go through seasonal forecasts, what they are. But many times with this talk or with different iterations of this talk, I introduce the seasonal forecast and say, here, this map is showing, well, this is back from last year when we still have that La Nina influence, and we could see some of those signals here. For example, in Indonesia, Malaysia, Philippines, down into Australia, and then also southern US or East Africa, for example. But yeah, like there's a lot of talk about how useful these are. Our seasonal forecasts are so useful. And full disclosure, this is a product we make at IRI. So I do think there are some use cases where this has influenced decision making, but it's really not that easy when you're an international humanitarian organization trying to think about how this could justify a change in the decision that you would make or an action that you would make. How would this influence a prioritization of one action over another, or deprioritization? And many times what it comes down to is there's more information, there's more maps, right? So on the right, we see this is the C3S product over the same target period. And again, the story here is that these are both trustworthy, right? These are both well-known. These comes from organizations of like sufficient repute, let's say. But and they in many ways they look similar. Sometimes I hear like, oh well, like they're telling a similar story here. But humanitarian organizations many times are focused on a particular country or a particular subnational area or a region, and they tend to focus on they tend to zoom in to that area because that's what they're interested in. So if we look here in Northern South America, Central America, and the Caribbean, like the story could be like, oh wow, like these are telling a similar story. Both are indicating above average precipitation over the coming months. And in some decision-making contexts, that could be useful. For some sectors, that can be useful. But for the humanitarian sector, it may or may not be useful. And in many situations, there's even more information. So this is a Outlook product from CARICOF, the Caribbean Climate Outlook Forum. This is a regional entity that issues a similar product. I mean, the representation, the visualizations are different, but still, it's telling the intent is for it to answer a similar question. And it's important to note that this is from a regional entity developed in the region, not a global entity. So there's also other issues around mandates, roles, and responsibilities that are very important to humanitarian organizations, regardless of the hazard that you're focusing on. And here are some questions that last year came across in my inbox. If there is an ongoing drought-related preparedness response plan in Hispaniola, so Haiti and Dominican Republic, should it be enhanced in the coming months? So to what extent do these three products address that question? And then what do you do when they tell a slightly different story or a vastly different story? And then on the bottom is another real world question. If the UN can prioritize 3 areas for flood preparedness in the region, what areas should be prioritized? Like this is actually how it works sometimes. These are the types of questions, and they say, Andrew, like what are the products? What's the data that we would like a data-driven process here. So can you help me? And sure, I could just pick one of these and send them, but it's more appropriate to identify the candidate data sets and then think more about how these can influence these questions. And essentially what the story here is, where does the accountability lie for me to make those choices of what to include or what to exclude? And that is a gray area that we could ignore, but I think it's important to be clear about that and describe that process, not only from a scientist having the privilege of selecting and endorsing and propagating products, but also thinking about, what does it mean for these decisions? What does it mean to influence the actions? What does it mean for different countries or areas or people to be prioritized or deprioritized based on influence from a now present data set or product? So it really comes down to these questions. And this is after discussions. There's a lot of talk about you need to engage with the user community and decision makers. So many times after doing the proper engagement, these are the questions that it comes down to. So we just spent an hour on a meeting or more talking about the different products and the issues with the products, but just tell us which one is the best and just tell us which one do we trust. Just let us know. And At first, when I first started doing this 10 years ago, I was very surprised that so many times it boiled down to this, because I was of the mind of developing more objective approaches, even quantitative approaches to perhaps fusing different data sets together, or averaging different types of spatial averaging, and making sure we have the right type of statistical analysis to show that some of these are better than others. But it's really not, in many cases, you don't have the time to do that. It's much more about understanding the appropriate ways to translate and represent the data sets that allow for the decision maker to retain the accountability and the agency, but also as a scientist understanding that you do influence, you do have a role in what gets selected or not. So this is an overarching, let's say, narrative that is present in no matter what type of work that I do, but very often it comes down to these questions. And yeah, it's not that easy. You can't hide behind the science at that point. You can't hide behind the data. You need to be present in thinking through these questions if you as a scientist want to be present in the full chain down to that decision-making piece, that action piece, which we hear talked about so much more these days in the applied science framing. So I also wanted to show this. We don't have time to go into the seasonal forecast, but this is the most recent seasonal forecast, and El Nino signals are very present. But this is something else. If anybody ever wants to talk about El Nino, not just myself, there's many people on the call that could do that, but I'm happy to talk about it. So we also covered some of this in a paper we wrote last year, this idea of climate science translators. Just saying there needs to be more translation of data really isn't fair, I don't think. So we wrote a paper outlining some of the roles and responsibilities that people establishing themselves on a career path at that intersection should have. And then we also have a methodology here to assess if and to what extent there is an increased demand for these traits related to climate science translators. So if you're interested in that, it's in BAMS, and I'm happy to talk about that as well. Okay, so the first case study we're going to go through is in Bangladesh. I'm going to try to get these case studies to 5 minutes each, which doesn't do them justice at all. But just so everybody knows, and we could talk about it, and then we can move on to questions. But yeah, I mean, this is a picture I took in 2017. And I hope everybody is familiar with the Rohingya refugee crisis. It's an ongoing situation. It's not a new situation, though. Ever since, I think, the 70s or 80s, there's been Rohingya refugees hosted in Bangladesh, specifically in Cox's Bazar, primarily, actually. And yeah, and in 2017, I was working with the UN Interagency Standing Committee on a few projects. And just over coffee, one of the days, someone was like, "Oh yeah, we're getting more concerned about the situation in Cox's Bazar. There's talk that there's going to be many more Rohingya crossing the border, and we need to ramp up the refugee camp operations there." And they're asking me things around questions around tropical cyclones, and it was interesting. The discussion started really related to climate change. They were like, "Yeah, we hear that." We hear that there's going to be increased likelihood and stronger tropical cyclones in the Bay of Bengal. And I was like, well, I think there's a lot more research that needs to be done on that point. But I was glad to hear they're thinking about hazards and thinking about the tropical cyclones as essentially multi-hazard events within the construct of a single one, and thinking about the landslide element, the flash flood element, the coastal storm, the storm surge element, the wind element. And that was good. It was interesting to see the time scale, I think, was a bit mismatched, but that opened up a discussion when they were asking me about what sort of risk information is available, what sort of forecasts are available. And my first response was well, we have the WMO Regional Center in India there, IMD, and the Met Department. There's Bangladesh Meteorological Department that most likely has forecasts that would likely be relevant for the Cox's Bazar. There's other regional entities. Essentially, that's my first step in supporting the humanitarian groups is what's available in terms of a mandate perspective, national government, regional. It's not about me making my own forecasts. I mean, that's that's something that is. I'm not saying I got into this work because I wanted to be an operational meteorologist in the humanitarian sector. That does come up sometimes, but mostly it's about identifying appropriate data sets, potential candidate data sets, and then thinking through the appropriateness of using them. And that was the case here too. So eventually I got asked to go to Cox's Bazar, actually 2 different occasions. The first time in early 2018, to help think through early warning systems, which ones could potentially be developed in Cox's Bazar. What does it mean for a refugee camp manager context? They hadn't thought about disaster risk reduction very much. It was very much thinking about disaster response, disaster recovery. And this is one of the first times IOM, International Organization for Migration, was thinking about standard operating procedures, more of a framework of disaster risk reduction. And that's what we worked on there. So this picture is one of the pictures that I took, Camp 10. And then this picture was taken much better resolution. Sorry about the other one. This picture I also took, I forget what camp this is, but there's a few things that stick with me here that I would like to highlight for everybody. One, picture was taken February 2018. And pre-monsoon. And one of the driest, hottest times in this part of Bangladesh. And I was working with the Intersector Coordination Group, which is the group that essentially builds the refugee camp, maintains the refugee camp in coordination with UN entities, Bangladesh government, and private sector as well. And the question that they were asking about flood risk maps. What kind of flood risk maps do we have for the refugee camp? What kind of landslide risk maps do we have for the refugee camp? These sorts of questions. And I remember standing on this hill looking down and seeing the ponding of water here. And as they were describing, you see the blue tarps on the sides of the building. Those are mostly latrines on the hill. And the questions around like, where is it going to flood? When will it very likely flood? And I remember thinking and having the discussion like, well, it's the end of the dry season. We're already seeing water here. And then we started talking about that, like what areas is there already inundation? And fortunately, we had access to drone-derived remote sensing products and able to map some of that out, but also able to get updated topographical data through SAR imagery with those UAVs. And that was really important because you could see the hill here, and then you could see that one tree on the top left. This was one of the most forested areas of Bangladesh. Those trees, that height of tree, covered this area. And to build a refugee camp, this land had to be terraformed. The topography changed, the hydrology changed, the soils systems changed, everything changed. So just talking through about the limitations of the existing forecast products and risk products, even if they existed, was one of the biggest success stories, let's say. Not introducing new forecasts or products, but basically saying, be careful because even if products exist, they're probably not going to be sufficient and they could potentially be misleading. And in this type of situation, it's really important to know that you're prioritizing the right camps. And we're talking each of these sub camps is 10, 20,000 people. It's really important to understand those gradients of socioeconomic vulnerability and how they align with establishing standard operating procedures, which essentially are going to use that forecast to justify prioritizing some groups and deprioritizing others. And this was a question that stuck with me, that still sticks with me. How big can the gradients of vulnerability be in a refugee camp? We're talking about the most deprioritized people in the world. Like we're talking about the tails of the distribution. But it comes down to someone needs to be prioritized and someone needs to be deprioritized. We could act like us as scientists aren't involved in that process. Or if we want to receive the benefit of being present in these discussions, and then going back to our institute, writing blog posts about how much we have saved lives, I think that the responsible thing to do is to understand that we do influence that prioritization. And I hope that would make us all better actors within this very complicated decision-making process. So that's a little bit of background. It's definitely not a success story. And again, well, I shouldn't say again, this is another case of there was a lot of maps. I didn't think that this would be a situation where there'd be a lack of data. It's got a lot of media coverage. All over the world, scientists and other groups are sending in their data sets. We have the best forecast. You should use this forecast. You should use this flood forecast. It was too much. So usually on Mondays, every Monday, the Intersector Coordination Group sat down and we reviewed what products, and we had to make a decision. I'm not going to go through these products. The point is that there's a lot of flood maps. And the people making decisions did not have the expertise necessarily to parse out, or the confidence to prioritize one over others. So even in situations that may seem data sparse in terms of what's accessible, definitely wasn't the case in this situation. And honestly, it's becoming less and less an issue in many humanitarian situations. Not all, but in many. So one of the biggest outcomes, and this is me as a physical scientist talking about one of the biggest, I think the most important outcomes of the whole of the work in Cox's Bazar, was on the social science side. Spending time mapping out the decision-making processes that were climate sensitive, and coming up with identifying what information, what climate information, what forecasts are currently being integrated into the decision-making process, why they are selecting and elevating certain data sets and forecasting decision-making, and then seeing if there's other options that could be complementary or perhaps supplementary. We wrote a report on this here, and this decision-making flowchart, we called it, we never actually really filled out the whole thing, but the point was to have a space to have discussions. What are the questions you're asking? What are the pieces of climate information using? Why? And what are the decisions that you're actually changing? You know, many times it was like, oh yeah, we use all the maps. All the maps are useful, but it's like, yeah, like, are you actually changing the decision that you're going to make? And it's like, well, not really. Like, there's a disincentive to identify. There's a disincentive to clarify, you know, when changes were made, or based on what information changes were made. So we tried to break that down a little bit. And just one example, one element of this I think is important to highlight, because I still think about this, it stresses me out. I remember one of the days we're going through this questions, and every Monday the intersector coordination group sits down, and the question they ask is, do we move the bulldozers and diggers out to terraform the hills this week? They need to make a decision on Monday. Is this going to be a week where they build new camps, essentially? And initially, they didn't really say this was a climate sensitive question, but the more we talked about it, I'm like, well, like, do you ever not send the bulldozers out? And they're like, oh yeah, if the forecast is for heavy rainfall. Then I'm like, okay. Then I'm like, well, what does that mean, heavy rainfall? And they're like, well, if the forecast says like rain every day. And I'm like, well, what is it? What if it's like a 10% chance? And they're like, oh no, not 10%. What if it's a 40% chance? Maybe 40%. What if it's a 90% chance for 2 days and 10% the other day? Oh, well, maybe. So these are the types of discussions going through to try to get a sense of like, what are these critical thresholds that exist that aren't necessarily perceived as such, which for a meteorologist are super interesting to think about how these exist, why, and understand what information is used to essentially trigger a deactivation of what is a standard operating procedure of moving the bulldozers out. So eventually we get down to the point where someone was like, oh yeah, I think we do use a forecast. Like, I think it was in one of the PowerPoints a couple of weeks ago. Go get the see if we could get this PowerPoint. It was like plugging in the USB sticks to find this PowerPoint. And they finally find it, and they're going to the end. They're like, yeah, I don't know where this forecast came from. And they're like, we'll show it to you. And they like go to the last slide. And it's a screenshot of Cox's Bazar rainfall for the next 10 days from a company called the Weather Network. I don't know if anyone knows the Weather Network, but it's like it's not. I don't know if Canadian Weather Channel is a fair comparison, but it's a private sector Canadian company, and I don't know. Maybe they have good forecasts. The point here is not like if they're good or bad. The point is why. Of all the available rainfall forecasts, the Bangladesh Meteorological Department, you know, the European like ECMWF, the regional centers, like how could this forecast for rainfall be elevated to such an important position to dictate building the refugee camp or not? Like, it's still to this day baffles me. But that's the baseline. You know, meeting people where they are is important. And I mean, I was shocked, but of course I didn't react the way I'm reacting now in that context. It was like, all right, well, let's talk about how this happened, and making sure at that point there was awareness of other information that is likely to be better, or at least think about what that choice of elevating that forecast is a very important choice, and there are alternatives. So yeah, that's a situation. That was the situation in the refugee camp, and we have more examples of this. But yeah, it was definitely a period of. It was another example of having a lot of data and not really that much time to identify and parse out and prioritize some over others. This is another case study in Malawi. I was working with the Red Cross in 2015, where there were devastating floods in Malawi, and there were questions around where to send resources first. And I took the picture on the left. That was outside of Blantyre, second largest city in Malawi. If any flood experts are here, this is a flash flood slash, it was primarily, let's say, intense precipitation induced event there in Blantyre. But then in the southern part of Malawi, in the top right here, we saw riverine floods. And then that's definitely not Malawi in the bottom right. I just showed that I showed this slide to students showing that this is another type of inundation. This is storm surge. I don't know where that's from. But in Malawi, the types of flooding were flash flooding in riverine flooding in southern Malawi. I was working at the Red Cross, but this led to actually the start of a collaboration between Red Cross and NASA that exists today. And this was an initial exploration of what could be done to help better understand that set of actions of disaster response. You know, if we had different types of floods, what remotely sensed products indicated the presence of different types of floods? What methods would leave out, you know, the identification of different types of floods? And how does that relate? How does that influence? How does that influence disaster response and disaster recovery? We don't have time to go into details here, but we have information on this. But the bottom line that I want to show you, oops, double slide, is that we were able to access data. If you look on the right-hand side here, we were able to access data on the flooded villages and the shelter site locations. And just doing a spatial comparison of what remotely sensed flood maps were used, not only within the Red Cross, or being sent to the Red Cross and the other UN entities involved in the disaster response. Many times the email was like, here's our flood map, use this to prioritize where to go. And me knowing that most of the loss of life was not caused by riverine floods, was actually caused by the flash floods. We had, I think, about 300-400 people die in Blantyre from flash floods. So the question was, if we're talking about prioritizing different areas in Malawi for response, we need to consider the time element. If we're talking about life or death, bodily injury, we want to know where the flash floods are. If we're talking about loss of agriculture area, loss of livestock, that's also important. But that doesn't necessarily need the urgent response that we needed in Blantyre. And unfortunately, what happened here, and we see from the products, if you see the reds and blues, this is a kind of a mosaic of different flood products that were sent claiming we're detecting the floods, go to these locations. Yes, this is where we saw displacement, but this was also from riverine floods. In the area, in the cluster in the center here, where you don't see any signal from red or blue signal, this is areas where we saw flash floods. And unfortunately, almost all of the loss of life happened in that area. So the message here was, yes, I do think the presence of these riverine floods and the incomplete messaging around the riverine flood maps made the situation much worse and increased the time it took to prioritize resources to the people who urgently needed them. So is this a compound event when you have riverine floods and flash floods? I mean, it's interesting. I mean, the driver of this event was actually a tropical cyclone going through, coming inland and kind of changing characteristics a bit, but essentially stalling over Malawi. An interesting discussion to have is, I mean, is Malawi, of all inland countries in the world, Malawi has to be one of at the highest risk of tropical cyclone impacts. This happens quite often, but that's what we saw here. And yeah, I wish there was a better end to this story, but again, like most of my talk is about the constraints and not the success stories. So my message here is sending out flood maps, just be careful. I mean, it's important what the messaging is very important. Talking about what it covers is just as important as talking about what it's not going to cover. So again, this is a broad overview. This is not meant to go into detail here, but I'm very happy to talk more about this if you're interested and send the papers. Oh yeah, I circled those. Okay, and that led to some activities. I was very fortunate to have the opportunity to work in Malawi for a number of years on flood-related activities. I'm not going to go through this example now because we're over time, and that's my fault because I'm talking way too much. But we are working right now on the first anticipatory action early action protocol for flash floods. I'm not sure how many people here are familiar with the anticipatory action community, but essentially we're trying to fill the gap between forecast availability, warning availability, and everything else that it takes to prioritize action in some neighborhoods or some locations over others. There are some, again, success stories for some hazards. For flash floods, we don't have any. So we were funded by the NASA Disasters Program, working with University of Oklahoma and also Ecuadorian Red Cross and the Hydromet Service of Ecuador to develop the first anticipatory action system. COVID has made this more challenging, but we're still moving ahead. I was going to talk about the different types of flash floods, but I'd rather get into the questions. But if anyone here is interested in the subtypes of flash floods, that's something that's coming up quite a bit in this work. In Quito, this is a picture of Quito, there is a very keen awareness of the different types of flash floods, not only in terms of their drivers, but their impacts. And questions around the appropriateness of forecasts of flash floods and what does that actually mean for the hazard that is flash flood and associated impacts. So in this picture, one of the local respected elder people is explaining to us one of the flash floods that impacted the northern part of Quito. And then this is the southern part of Quito. This is like on the dry side of Quito, let's say. I'm very happy to talk about this. This is ongoing work. One of the interesting parts of this work is that Ecuador actually has a fairly extensive data set of historical floods. I think there it says right here, 3,300 at admin 3 level, XY events with XY locations over 2,000. It's not bad. However, they were only labeled as flood. So that means various types of floods were included here. And our task, in order to appropriately or best train the flash flood model that University of Oklahoma is leading, was to disaggregate the historical flood database by subtype of flood. This is not even getting into flash flood subtype. This is just, we have a lot of historical data. It's only labeled as flood. To what extent can we assign a subtype, and what are the and how do we come up with some sort of structured method to do that? So we did that. And we have a paper on this as well. What's the interesting part here? Oh yeah, so after different filtering steps and looking at both the geophysical elements of the locations where they occurred and also text mining, we identified 975 potential flash flood events that we classified into a confidence level from 1 to 10. And this is the distribution of those, also color-coded by the confidence that we had and that these are actually flash floods. And we have some low numbers that we could filter out. But the cool thing here is that we could adjust, our tolerance here. If we only want to include events that we are very certain are flash floods, we could pick the 8, 9, 10. Of course, the N is smaller. So we have some flexibility here depending on what we want to do. And we have the methods here, and we have a paper. Sorry to run through it like this. I thought I would talk faster, but we saw some interesting results. So if you look on the bottom left here, we saw, depending on the flash flood class, we could see a distribution difference. We look at the distribution here by month, and we could see that there are some flash flood classes that happen in different months. And that was a big part of this, to think about the seasonality of flash floods. There was a sense of different types of flash floods happening in different seasons. So we have this peak in February, March, April, but then it's kind of not secondary peak necessarily, but a different type of flash flood, a different type of spatial distribution of a different type of flash flood in October, November. And this is the method that we're using now to parse that out in order to develop an early action protocol for anticipatory action. Okay. And that will, no.
Do we want to go to questions, Andrew?
Yeah, I'm going to go to questions. So I'm just giving a shout out to the team because I think that's a good way to end. So this is the team in Ecuador Red Cross, and then these are colleagues working on the project. So let's stop there. We could go to questions. Sorry, I kind of went over. Maybe that happens otherwise, but.
Well, like I said, we usually end up getting to an hour, and easily in this case. But yeah, thanks so much. That was really interesting, and among many other things, you really underscored, I think, the difference between decision relevant information that scientists are always talking about, and decision affecting information. So hopefully everyone has had a lot of time to mull this all over and think about some questions. And I guess, Mona, do you want to lead the Q&A?